Thanks for the intro. That was a very nice way of saying I have research ADD and I do all kinds of crazy stuff, some of it connected, some of it less so. I do work at the intersection of AI and HCI, and what I wanted to talk a little bit about today was where I saw that working well and where I saw it working less well, which was more of an opportunity to do better for you guys and for myself as well. What I want to start with is sort of the good old days of, I should say 2018. But anyway, what I want to start with is the good old days of when we started thinking about integrating AI subsystems within different kinds of GUIs and frameworks. And so let me start with a dumb example, which is maybe from 17 years ago of somebody coming in and working on designs for Word, and the engineer comes in and says, this is the HCI designer comes in and says, dude, like every Word user, what they really want to do is when they make an animal noise like meow or whatever, we really want clip art to be added into the display, right? So really a great feature for Word users. You say ba, you get a sheep, and it's great. Okay, this is going to be the AI feature that I'm going to build in. And so the designer would come to the AI engineer and say, can you build me a system that does this? And the AI engineer would say, totally. Like, here's a black box, and just so you know, it's special. It's a magical black box, and it will do exactly what you ask for. Okay, so the magical black box will do this feature for you. You say meow, and it'll give you a cat. And I say, I'm the HCI designer. I say, well, is this really reasonable? Like, are you actually going to be able to give me a very clean API for doing this? And what I mean by that is known inputs and very well-known outputs. And you get, sure, from the AI person. I'm going to give you this interface where you can make sounds into it, and out will come, a great thing like a cat. Okay, so this will be awesome. This will work exactly the way you want it. But, says the AI engineer, look, it'll work almost all the time, but there are certain situations where I just want to get a little bit more information from you, like what version of Word is it? Are they in a noisy room or not in a noisy room? Like a little bit more detail would be nice. So not just saying meow, but can you tweak a few knobs and levers for me so that I can do better? And the designer says, okay, fine, I'll add a control panel into this. So it's not just going to be as clean of an interface anymore. So I'm going to give up a little bit of that clarity. But look, the designer says, the output is going to be clear, right? Whatever you tell me, like if it's a cat, you're going to say cat, right? Well, says the AI engineer, I can tell you that it's 60% a cat, a 30% chameleon, and 10% eel roll. Is that going to be good? And that's a little bit of clarity that now I'm going to have to give up. So now I'm starting to get a little bit worried as the designer. Am I really going to get what I want? Like maybe I can take the max value here, but this wasn't exactly what I was expecting when I was thinking about integrating this AI system. Okay, fine, I say. I'm the designer. The model is going to be stable, right? Like the inside stuff over here in this box, that's not going to change, right? Like that's going to be consistent. You're not going to ask me anything else about training or anything like that. And the answer, of course, is, well, it'd be really nice if every once in a while I collect a bunch of information, like training examples, like maybe the person wants personalized recommendations. Maybe they have really specific differences in the kinds of cats they want to see. And so, yeah, I can't really say that you won't be required to give me more information. And so now this nice looking black box is starting to look a little bit more monstrous. And so now you have this demand by the AI engineer to feed the model in order for the model to work well. Okay, so fine. So I lose this kind of simplicity, this model stability. And the last thing, so the designer comes in and says, well, you've forced me into this terrible situation. I mean, look at this thing. I started wanting this nice, clean black box, and now I have this thing. So at least, please tell me, will you be able to explain to me why you made the decision that you made? Like, will you be able to tell me why it succeeded or failed or whatever it was? And, oh, yes, says the AI engineer. I have just the ing for that. I'm going to put Andrew Ng inside, and he's going to hallucinate some decision trees for you. Okay? This is going to be the explanation that you get about the decisions that we make. And by now, if you're the designer, you're saying to yourself, what the what? Like, do I really want this terrible, awful thing that I thought was going to be a clean black box with this nice interface, and instead I'm going to get this guy? They're too old. They're too young for Clippy. It's so sad. Nobody thinks this is funny anymore. It used to be funny. All right. So our nice, cute interface now has to be shaped by the constraints of this terrible black box, which is not actually a black box. So the simplicity that one expects as a designer is not actually manifested in the way the thing is actually built. And maybe you're thinking to yourself, well, gee, that's 18 years ago. Like, you must have made some progress today, like we're looking at today. And yeah, it'd be nice if UI and AI people are on the same page. But even 2 weeks ago, you get exchanges like this. This is from Feifei, making AI more sensitive to the full scope of human thought is no simple task. Well, some snark from Jeff Bigham, who does HCI research. Oh my God, if there was a field that did this already and it was well established. I mean, connecting cognitive science with psychology, as if like, you know, the expectation that everyone should be aware of HCI, you know, everyone should be aware is the claim here, and some people are not. And maybe that's reasonable, maybe not. You know, what is this thing? What is this thing that we've actually constructed that is useful from the AI perspective? Like, have we actually come up with mechanisms to bridge those things when you have these noisy systems? So tell me more about the solution. And you know, the AI engineer might say, you've solved this, right? And so let me answer in the way an AI engineer would expect an answer back, which is 60% yes, 30% no, and 10% fish taco. Okay, so this is how close we've come to solving this problem. But let me talk about what's actually solved and what I think still needs to be done. I think we've gotten pretty good at some specific tactics for hiding the problem and some specific tactics for showing and allowing control of the underlying AI subsystem. I think we've come up with higher level strategies, but they're not perfect, especially given the changes that we're seeing today in the way AI systems are constructed. And so I think we sort of kind of have a design language to support this. And by design language, what I mean is a set of patterns that we will use over and over and over again in defining user interfaces, okay, for the use of AI subsystems. Okay, as well as like specific looks and feels. So what does the UI actually look like? So not just the pattern, but the actual UI. And I think we're getting there, but I think there's still a lot of gaps, and I'll come back to that towards the end. I will say that the thing that will drive most of the solutions that I'll talk about in a second are two observations that have been made both by AI people and HCI people, which is this. Uncertainty sucks, and you got to learn to deal with it. Like, we are going to be producing uncertain output from the AI subsystems. Okay? The other thing that you have to learn to deal with when you're dealing with this is fault tolerance, and this becomes an important and critical aspect. And I think these two things are going to drive a lot of the solutions that I'm going to show you. Things like explanation, by the way, fall into specific tactics and strategies for dealing with this. And I'm not talking about explanations for things like bias, for example, which we can come back to later. So just to be clear about what I mean about uncertainty is if you have a cat, uncertainty means I tell you it's an American short hair or an American bobtail with a different level of confidence. But what I mean by failure is I tell you it's a fish taco or don't give you an answer at all. Okay, so those are failures. And then there's everything in between. Okay, so there's some combination of uncertainty and failure that may manifest in the inclusion of the AI subsystem. So this is the combination. Separating these two things out, this is how I like to think about this, as being two different things. And there's some areas where they overlap, but not always. There's the uncertainty aspect, and the specific strategies that I'll talk about are either hiding the uncertainty or allowing control of the uncertainty by showing something about it and giving interactive elements. The other dimension is how we deal with failures. And again, we can have the hide and the show. Okay? So those are different strategies for doing this, and depending on the specific kind of AI you have, the specific interaction of that AI with the end user, you're going to have different points in this space. So sometimes you're going to want to show things, sometimes you're going to want to hide things. But is there a regular principle about talking about this? Let me start with this corner over here, which is hiding a lot. Okay? This is one of the areas that I'm actually interested in researching, and I've done a bunch of work in this, specifically around benevolent deception. So we published a paper about this in 2013. And if you want to see lots and lots of great examples, I guess I would refer you to this paper. I'm going to pick out a few of what I call benevolent deceptions and how you might implement them in the context of AI. So what do I mean by benevolent deceptions? One of the examples that I really like in this space is this one. So Yoki Matsuka, who was a professor at UW, went and worked for Nest, had a robotic rehabilitation arm, and you would arm wrestle with this thing, okay? Basically, if you lost motion due to an accident, due to whatever, you would arm wrestle with this robot. And it would basically improve your strength. And the way they would measure sort of how far you've gone is maybe by degrees, let's say. So how many degrees have you bent your arm? It turns out that people have mental blocks around how far they're willing to go, okay? So I can go more than 10 degrees, but there's something that says, in my mind, I really can't. I just can't. I'm going to block on going beyond the 10 degrees. Like there's no way I'm going to push this to 11. So what did the system designers do? The system designers lied. The system designers said, when you're actually at 10, they said, you're at 9 degrees. And the person would say, well, okay, I went to 10 yesterday. I'm going to push it one more. I'm going to get back to 10. And now they're at 11. This is an active act of deception, right? The system designers decided to implement their solution in this way because they valued the person's arm motion, and they believed the person valued their arm motion more than the truth. And so there was an active deception on the part of the system designers, and the person couldn't tell the difference because of physiological limitations, like just noticeable difference stuff. You would not actually be able to tell that the system was lying to you. An active deception, benevolent deception. Here's another one. This is one that got me thinking about this space. Michael may know this because this is something that we were taught in systems class at MIT, like 033. I don't know if you've taken it, but basically we were taught about this old case of a telephone switching system. It was called the number one ESS. And the number one ESS was this huge, monstrous beast that would basically connect phone calls. Okay, and you would dial in, and there was some mechanical and electronic infrastructure that would make a connection. Turned out that every once in a while in most cases it would connect you to the person you were actually calling, there were situations where it would connect you to the wrong person. Okay, and the system knew that it was making this mistake as it was making it. Okay, there was actually infrastructure in there to detect those kinds of misconnections, but it was really hard to do anything about it. Okay. One solution might have been to hang up. Another solution may have been to put on a different dial tone. A third solution may have been to put on an operator saying, oops, sorry, can I connect you to the right person? What they did instead was just let your call go through. Okay. And this happened rarely enough, and they did not charge you for this phone call, so that you were like, fine, whatever, maybe I misdialed. Okay. It was an act of deception by the system designers that basically made this, pushed the problem onto the end user. Okay, that's a little bit of a strange thing to think about, but they did this, right? And so what I started thinking about is what's the spectrum of these things in terms of benevolent and malevolent, in terms of deception, okay? This is a bit of a hard line to think about, and I would say lying to save a life, that's probably on the benevolent side, and most philosophical thinkers in this space would probably agree that lying to save a life falls into the benevolent side. There's stuff over here like shopping cart manipulation. These are what I call dark patterns, or other people call dark patterns. This is like shoving something into your shopping cart, and then you don't know about it, and when you hit checkout, you get charged for it. Right? That is called a dark pattern, and that's probably on the malevolent side. The benefit to me is very limited as the consumer. The benefit to the company is clear. Then there's stuff in between, like the robotic rehabilitation, the number one ESS, which both benefits potentially the person because the interface, like sort of, it's a smooth thing. The connection to the other party on the phone is smooth, but it also benefits the provider because they don't get annoying calls saying you connected me to the wrong person. I hope you're not charging me for this bad phone call. So in that situation, both the end user and AT&T benefit from this deception. Things like placebo buttons, I don't know if you consider those malevolent or benevolent, buttons that you click to make you feel good about clicking something but don't actually do anything, like crosswalk signs in some places. Temperature gauges, sometimes those are fake. Anyway, these are examples in the spectrum, and I would say that there's stuff that's clearly malevolent and some stuff that's clearly benevolent and some stuff in between that we can argue about. Okay, I'm mostly going to talk about stuff on that side when we talk about benevolent. And I guess the reason, the way I would ask you to think about this is who benefits from the particular act of deception. Okay, so why do we think about this, and why am I thinking about this in the context of AI and UI? we talk around deception, okay? Most people do not like to think about actually deceiving the end user, which I think raises a bunch of problems. We talk about theater, we talk about magic. Like those are the things that we use, like the metaphors that we use when we talk about these acts that we do that are actually acts of deception. I think failing to treat it as actual deception makes it hard to design these things properly, effectively, and ethically. Okay, so my push has been in working on this is to stop thinking about these as like, oh, it's just theater, oh, it's just magic, and actually think about it for what it is, which is a little bit of deception. The reason why deception works, and I'm going to get to specific examples of implementing these in a second, is that there's tension between what we want the system to do and what it actually does. So there's a bunch of situations where there are these tensions. So we've talked about this uncertainty and failure, and those things create these tensions. So let me give you a specific example of a tension, which is that when I implement something, okay, I have the system image, that is the representation as it actually is. So I am the designer and the AI engineer and whatever. I'm the person building the product. We build the system, and that is the system image. The individual, the person who is actually coming and using this, has a mental model of what that system is, okay? And the difference between those things is the tension, okay? The way it actually is and the way I think it is. That difference is actually a situation in which people are often using deception. So why do we do it? Like, what are specific examples? In many situations, we do it because the system has uncertainty, and the uncertainty may be of many different sorts. There may be some problems with how smart the thing is, how fast it is or slow it is, how reliable or not it is. And so the things people do are as follows. In some situations, AI systems are actually too certain. Okay? Playing a game against a virtual billiard player is not very much fun. The AI system can score perfectly every time, right? Like there is no reason one would ever lose when playing a game like this against a virtual partner. And so the game designers said, yeah, this is not really fun. We're going to build in artificial stupidity. Okay, we're going to actually cheat, and we're going to make the systems dumber than they are so that they're actually more fun and more pleasant. That is an act of deception. Okay? We are dumbing down the system. We are not actually making it work as it was implemented to work because we want to match the expectations of the end user, which is that they're playing a human being and not a computer. This is probably a much more familiar example to you, the progress bar. And the progress bar, of course, is often an act of deception because the stuff underneath, that's not running like at the rate that that progress bar is moving. Sometimes the system doesn't actually know how long it takes. Sometimes they do, and they just want to make you stick around. There are various reasons why the progress bar motion does not actually meet the reality of how fast the system underneath is going. This is another act of deception. The third one, and people argue with me about this a little bit, but I would say this is another example. In this case, engineers designed a car. It was an electric car. The electric car did not make the same noise as a standard oil-based, gasoline-based automobile. Okay, it did not have those engine noises. And this is a problem, of course, if you're backing up and no one knows you're there, and this is an issue, right? Like you don't want to be running over people and things like that. You also want to know that the car is running. Okay. And you could engineer a solution to this in a bunch of different ways. The way they decided to do it was actually implement a speaker that would make noises that made it sound like it was a real car. Okay. So the expectation of the end user that they're driving a car that they're familiar with were being unmet with the electric engine. And so the designers had to add a little bit of glue in there to make that fit. Okay, the expectation of the end user, the person driving the car, and the people around the car were different than the way the car was actually behaving. The other tensions that exist are often in the design principles that we actually teach. So this, I always feel bad when I teach HCI classes because we tell people all these different kinds of things about how they should build their systems. And oftentimes there's a conflict between these different pieces of advice. So things like, oh, you should fail gracefully, and oh, you should not fail silently. Like these are things that may not work together. So these things also create tensions and sometimes necessitate the use of deception. Let me give you a few more examples about specific strategies and how they work when we choose to deceive in HCI. Some of the deceptions work based on psychological principles, so things like just noticeable difference, the inability of a human being to tell the difference between different shades, to tell the difference between different kinds of touch, how far they've moved with their arm wrestling robot, things like aesthetics, relying on things like change blindness. All these different aspects are things that we can manipulate in making deceptive systems that work. This specific one that I want to mention is a speech recognition system. This is kind of older. There were two systems, PhoneSlave and Grunt. It turns out that when you're doing speech recognition, this was one that was specifically intended to answer questions. When you're talking to a computer and know that it's a computer and sort of have that expectation, the inflection for questions is different than when you believe you're talking to a human being. So when I ask a question like, what's the weather today? I will say it differently to you as a human being than I might say it to my Alexa, which is, what's the weather today? Right? That lack of inflection at the end that tells me that it's a question is problematic, it turns out, for these speech recognition systems. So what they did was they actually anthropomorphized the system on purpose. Like they created this thing that said, I am a human being, treat me like a human being, talk to me as if I was a human being, because it turned out that the AI system could work better when it believed, or it was when the person who was interacting with it believed that it was a human. The speech patterns changed in a beneficial way to the AI system. That is an act of deception, I would argue, because that is not the way it works. It is not a human being, but portraying itself as such got the human being who it was interacting with to do the right thing in terms of generating the right answer, or sorry, generating the right way of asking the question. Another way that people do this is something that I call mental model deceptions, like manipulating metaphors, using things like skeuomorphs, making them look like the physical analogs, which has become less popular, but was popular for a long time. Basically making your calendar, right, in your Mac OS look like a physical paper calendar. We don't do that quite as much anymore, but that's a skeuomorph. These game designers built a game where you were interacting with police officers. Okay, so you were interacting with a virtual agent that was a police officer. It turned out that people did not believe this was a police officer. I mean, for obvious reasons, but they sort of were unwilling to suspend disbelief. They were sort of uncomfortable with interacting with the system. It was not fun for them. So what the system designers said was, fine, okay, we're going to tell people this. I am not a police officer. I am an actor playing a police officer. When they did that, while not believing in the role being real, the user was tricked into believing the meta role was real. It's kind of clever, right? I'm not a police officer. I'm an actor playing a police officer. Still, I'm telling you I'm a human being of some sort. I'm an actor. And because one expects actors to not be very good in some roles, you're like, fine, whatever. I'll believe that you're a police officer. This is an act of deception and one of many that we found. These worked in our study, in our understanding in these situations, which is that oftentimes users were willing to suspend disbelief. So end users were willing to be deceived in a way. The value of the system was high when the lie was treated as truth, whether it was completely hidden from them or whether they understood it to be a lie and were just willing to go with it. An example of that point of understanding that it's a lie and going with it is this. So You Don't Know Jack is a trivia game that used to, I don't know if it still exists, but people used to play this. And this is from their manual, and this is a paraphrase. The user will spend a few minutes trying to identify the limits of the eye, so pushing it, and then they would get bored and go back to enjoying the game. This notion of suspending disbelief. And so maybe a reasonable question is, now that we can deceive, is should we? Well, so can we? Yes. Should we? The argument that we made in the paper when we first talked about this is one should apply the principle of veracity, which is that deception should be a last resort. Okay? That it is appropriate in some cases, but again, it should be a last resort. Okay? And the notion is, should we try for these reasonable alternatives? And so let me give you some of these reasonable alternatives at the intersection of UI and AI. So just to summarize this last bit. When we choose to hide stuff, okay, like let's say the AI system says, here's a bunch of different things that I think this image is. I think that's a kind of dog at the top and a soccer ball at the bottom. So this is my uncertainty presentation. And so in the act of hiding, what we're going to do is remove the uncertainty. We're going to block that and also remove all the other choices. So I'm just going to tell you that it's this kind of dog because that's the best guess that I have. So this is on the hide side. The show control side is basically asking, can we find a way of presenting this information in a way that is useful to the end user? Okay. I'm going to argue that there's 3 different ways of doing this, and there's probably others, but this was the easiest for me to think about when I was drafting this. There are places where you can show and control the uncertainty and the failure by changing the entire interface. So this is at the very high level. I'll give you examples of all of these. There are places where you're going to dynamically change just a piece of the interface to support uncertainty visualization and control. And there are places where you're actually just going to change the widget at a very low level. So the entire interface, some smaller chunk of the interface, and some very specific chunk of the interface, the widget. At the highest level, and there are not very many cases of this where we change the entire interface, I would argue that search engines sit in that area. And companies like Google have trained us well. Okay? We are no longer surprised when we go and type in a query and the entire interface looks different than the way it looked last time. It does not affect us in any way when we click on a link, and I would ask you to try this on some of your searches. You click on a link, you go back, and all the search results change. Like, do you even know that this is happening? The entire interface, except for that search bar at the top, is being dynamically changed, even at that level of like going off to a website and coming back. Which is pretty crazy, but Google's trained us, and so we're fine with it for whatever reason. But we're showing you the uncertainty. Like, all the things are being changed dynamically, and people are sort of OK with it. The intermediate stuff, which I would argue is by far the most common, are things like this. So this is a very nice example. Erica Virtue at Facebook wrote this really nice Medium post about this, talking about designing this feature, this recommendation feature inside of Facebook. The recommendation feature was you would say, give me your recommendations of hair salons in San Francisco. And the expectation was that a bunch of people would give you recommendations and you could collect it. And they started thinking about, like, how could we make this experience better? And the way they started thinking about that is by using something called entity resolution. So figuring out which thing is being discussed in the interface, like by the person typing the thing. So this person down at the bottom is saying, I really like the Riverwoods Day Spa. Okay. Facebook would recognize the Riverwoods Day Spa as being a thing, a physical business. It is in San Francisco because we were talking about San Francisco. And so they would create this little box down here where you could go to their page, get directions, figure out how much they cost, look at other reviews, and so on. Okay, so the person typing that statement in didn't actually create that link. That was done through the AI. And of course, entity resolution is imperfect, as all AI technologies are. And so what they said they were going to do to deal with this problem is break this apart. And they were going to do 3 different things. So if they had high confidence in what you were typing, there was only one Riverwoods Day Spa anywhere near San Francisco, then we're just going to show you this box, and it's just going to have all the details, and that's it. We're done. Okay. If my confidence is medium, like maybe there's a bunch of different Riverwood Day Spas, or maybe I'm not sure, I'm going to give you something like this. So slight augmentation of the top level where you can say it's the wrong place or this is the right place. So getting the feedback, that control, pushing that control back to the end user. The else was this. I have no idea, just recommend a place. This is a little bit of psychological manipulation to get people to actually give them the information, like getting them to actually link to the page. But nonetheless, even though they had some estimate of what should go in here, it was too low confidence, and so they made a decision about showing that uncertainty in a very different way. So depending on the situation, they would use very different techniques. The blog post does a much better job of talking about the reasoning, but that's the high-level gist of that particular decision. The other place where we see this a lot, and this has been going on for a long time, are thinking about splitting the interface between things that are stable and things that are highly unstable. So this is an example implemented in Emacs. Do any of you use Emacs? Make me feel old. Okay, good. A few of you. When no one raises their hand, I know I'm in trouble. Anyway, so Emacs, this particular agent was implemented. So as you typed a bunch of stuff, it was constantly making recommendations. So there was a stable part of the interface. The stuff at the top was stable and controlled by the end user. The stuff at the bottom was unstable and being fed constantly by the AI. So you had some notion of like, this is particularly stable. I always know where I'm going to get this particular piece of information. And then a bunch of uncertain, failed, whatever stuff was at the bottom placed separately. This is maybe a better example, a more modern example. I would say this is not as popular to do these days, but things like adaptive toolbars were the rage for a little while, where there was personalized tools being added based on my expectation as the AI designer about what you were going to do next, as well as what you've done in the past. So that personalized toolbar was over on the side, and it was adaptive and constantly changing. But the decision was made, and this turns out to be a reasonable one, is you always have some stable stuff, okay? And then the unstable stuff is always over there to the side. So it's localized and controlled. People know where they can get that information. It is often of value, but when it fails, you can still get to what you actually need. So this is an example of these split kinds of interfaces where some stuff is stable and some stuff is unstable to deal with uncertainty and failures in the underlying AI system. At the lowest level, and we don't see much of this these days, are actual widget manipulation, so changing the look and feel of the widgets to display uncertainty and failure. This one probably here is the best example as it relates to this thing. Basically, this is Wesley Willett and Manish and Jeff Hare did this a while ago. They thought about ways of placing additional information like color or visualizations on top of existing widgets. So over here, you might imagine like I give you a bunch of results back, and I can encode through color, through ranking, the different options based on my level of confidence or uncertainty. Okay, so we actually, as a research project that I participated in, started thinking about how to build this in to an actual system. And we built something called Data Tone, which was a natural language interface that would allow you to construct visualizations. And so you would ask a question. You could either do this through speech or by typing. Show me medals for hockey and skating by country. Okay, so this was an Olympics database. We had a bunch of AI subsystems working on this, and I'll talk about why that was a problem later. But each of them tried to do a different thing. The first one tried to do speech to text. The next one tried to do part of speech tagging. And in each little step, we were making more uncertainty. Okay, so we had this whole collection of things that could go wrong that was being produced by these serially placed AI subsystems. What we did is we said, okay, every widget in our interface is going to have access to that uncertainty space. And we were going to bake in what we call uncertainty widgets, which is that each widget, like drop-down box, selection box, whatever it was that we were creating, was able to show additional information by pulling out relevant things from the uncertainty space. Okay, so users would have control, like they would see that there was uncertainty, and they would also have control over the decision-making process, and they could tweak and basically select from that list. This extended beyond just the parsing to also the visualization generation, so making decisions about which visualization was best, what the particular encoding. Like this was done through an AI subsystem. And again, the interface, like in this case, it was a selection box from 2 different chart types. Each widget could basically make a decision about what to show so that the user could control the underlying uncertainty of the AI subsystems. So let me move on in the last little bit, and hopefully we can have a little bit of a discussion about this at the end. So is this good enough? Like, are we at the point where we have enough techniques, okay, as UI designers, like we've built enough of these things that we actually can say we're done, okay? We've solved this problem, just like implement the solution in one of these few different ways, and we have examples and it'll be great. I would argue that this is not quite the case, okay? The first challenge that I'll bring up is this. I don't think there's actually a very good workable solution to making these implementation decisions. So choosing between a bunch of these different options, I think is actually very hard to think about. Eric Horowitz, many years ago, here's him holding a robot, came up with mixed initiative interactions. Do you guys talk about this Do they know what mixed initiative is? How many? Okay, how many have heard of mixed initiative user interfaces? Okay, very quickly, mixed initiative UI was a way of thinking about the interaction between a human and an agent, where the agent was going to make a decision about presenting some information or taking an action based on utility. Okay, so what is the expected utility if I act on behalf of my user, like fill in this form for them, interpret this scribble as a specific word, whatever it was. What is the value to the user if I did that? What is the value to the user if I get that wrong? Okay, so there were basically 4 different points. Treating the utility, like, is this a good decision? Like, was this what the user actually wants? And how much will it benefit them if I make this decision? How much will it harm them if I make the wrong decision, and so on? So people started thinking about this as a model for deciding when to use a particular AI subsystem, like when to trigger it and actually use its output, given the underlying uncertainty of the thing. It was really nice, okay? It was a really nice way of thinking about the problem because it allowed us to think in terms of decision theoretic terms, things like utility, like what's the value and what's the cost to the end user if I make a certain kind of mistake or show a certain kind of thing. It also was able to fold in things like asking the user for input. So if the system failed in some way or it was uncertain in a certain way, we could make a decision based on these decision theoretic terms. Should I ask the person whether I should take this action or not? Or get a little bit more information that would sort of up my confidence in my decision? Okay, so what is the value of doing it? What is the value of asking a question? These things were really, really, really hard to implement, okay? They're really hard to think about, which is probably part of the reason they're not taught everywhere. The specific instances of them, like how to actually measure utility, is tricky and difficult. If you need no other example of the, an argument against this, is that when first presented, like when Eric first said this would be a great thing, the actual implementation was this. Okay, and this is not mixed initiative user interaction. Like everyone says, oh, this is like an example of why this is a messed up system. It's actually not that the underlying system is bad. It's just not mixed initiative interaction at all. What the UI designers went and did was actually very different than the conception, the underlying conception. Okay, so it was a very different implementation. Because thinking about the utility and all these other things was highly problematic and highly difficult. So the main point I have, and this is where I think we need better research, is giving some ability to designers to go from thinking about those decision theoretic things into the actual interface. So what does that look like? I think this is a really, really hard problem, and I'd love to see more research in this area. All right, second challenge. Second challenge is this. It used to be the case that when we built an interface, maybe we'd shove in one AI feature. Yay, one AI feature we can sort of think about. What happens when we have a zillion AI features underneath? This is more and more the case. Photoshop, I'm at Adobe visiting for my sabbatical. They have a zillion different kinds of AI subsystems that do different kinds of things to the images that you're looking at. This particular one came out a few months ago. It was basically a really nice technique to figure out foreground from background objects. You would click on a button, it would find the foreground object, the robot, and hide the rest of it. There were a bunch of controls for this over here, a bunch of sliders that you would use to control. Okay, AI system number 1. AI system number 2. Michael, you don't smile enough and your head is not big enough to contain your brain, all right? This is called the facial liquefy tool. It is a feature of Photoshop. You might not be able to read the sliders over here. It's a smile, upper lip, lower lip, whatever. And if I manipulate the slider and forehead gets a little bigger, sorry. This is another AI-ish feature. Basically, it figures out what the face is, builds anchor points and all this. I gotta embarrass you a little bit.
Please
continue. So here's the thing. There are probably much more appropriate ways to do this kind of facial manipulation rather than using these sliders. Okay, there's probably other kinds of interfaces that are much more natural in order to manipulate these things. But you have to think about the fact that you have many, many of these things built into the actual product. And so the question is, what trade-off am I willing to make between the best interface for a particular AI feature and the best interfaces across all the different AI features that I have? In this particular case, I would argue that they went for consistency, right? Like it's a bunch of sliders sitting on the side, and that's a consistent interface to the underlying little bells and whistles of the model. And this is going to become more and more of a problem, not just within a product, but across all products. So we have to think about sort of the ecosystem of AI subsystems, not just within our particular designed product, but also what everyone else is doing. Having an inconsistent design language, in fact, not having any design language at all about how one should interface with AI subsystems is going to be problematic. And I don't think we're thinking about this. The next problem is what I call AI chaining, and I mentioned this before. This was in that data tone system that we built. It turns out that AI systems are not just working in parallel or one-offs. You're actually chaining a bunch of these together. So the input of one becomes the output of one becomes the input of the other. So in this particular case, speech to text feeds to NLP. NLP feeds to like a DB mapper. DB mapper feeds into visualization generator. Okay, so all these things are being chained, and uncertainty sort of builds up, and failures build up as it goes. And thinking about what that would look like in the interface, I think, is a hard problem. This is one way of doing it. I would love to see more. Challenge 4, what are we explaining? There's a lot of interest right now in explaining sort of how the AI subsystems work. This is a really nice example if you're a machine learning person. Okay, I don't know if you've seen this. This is Chris Olah and a bunch of other people at Google. They have this distill.pub, which is a website that has really cool things for explaining how machine learning and neural nets and things like that work. You have a dog, and this is like the hallucinations and whatever. Like, I'm not going to get into it. It's really cool. It's really cool if you're an AI person. I can't imagine anyone wanting this, okay? Like an actual end user, I don't think this is like the right way to explain anything. I'd also argue that the number of end users who actually want object recognition at this kind of level, that's limited, okay? So I think the AI focus right now has been a lot on things like object recognition, and I think that actually does not have a very good basis for use in most end user applications, but we can get into that. I think the other extreme, this is what other people do. This is a clinical support system for sepsis patients. This is the explanation. Okay, here's a bunch of reasons why I think this patient has sepsis. And this is pretty crazy. Like, this is like nice and friendly. This is like pretty insane, right? Like, that's the other way of going. Both these things, I would argue, yay puppies and yay sepsis, which are particularly yay, well, maybe puppies. These are expert systems. Where I think we're failing, and I think I'd like to see us doing more, is helping people make AI decisions and explaining AI decisions around things that people do all the time. So figuring out your retirement portfolio, picking between a bunch of insurance companies, making car recommendations, and so on, things that non-experts need to do. How do we explain to those people the underlying AI suggestion? I think that's hard. Challenge number 5 is these guys. Hopefully I don't need to say too much about that. The expectation, like a lot of the patterns, the design patterns that we've built so far have assumed a big display, a big screen. They don't really work when you have no screen at all or when your screen pixels are limited. So what does the design language look like when you shift to a lot of these devices? And there's many of them, and they're all acting differently. This is going to be a problem because, again, this ecosystem of AI-enabled things that are not displaying information in the same way. The last one that I'll bring up is this, which is that I think the models are actually changing a lot. It used to be that I would give you a model, the AI system would sit on your desktop, and it would never change. And that was nice and great because you had a lot of control. Like, there was some certainty about what it was that black box actually represented. Today, because we can have these AI subsystems elsewhere and it's easy to deploy and change them, what we're actually seeing is a lot of people making changes to their services quickly, okay? And they don't have to wait to deploy the next version of Word. They can just make the change whenever they want. Thinking about what that means in terms of the interface, I don't think we're quite there yet. Okay, I think that's another challenge that I'd like to see us working on. So where does this leave us? I think we've gotten better. I think we realize that AI subsystems look more like this and are not as friendly. And we're not building these anymore, which is also good. I think we've come up with good tricks. We have lots of great examples and strategies and tactics. And in other words, I think we have the start of what I would call a design language in this space. And here's the buts. The buts are this. I think we in the HCI side aren't really keeping up. I think we're sort of struggling to keep up and not really understanding the nature of how fast change is happening in the space. Okay, so this kind of parallel AIs in the interface, things like that, we're not really thinking about that either in the research or in development. I think on the AI side, there's also lots of problems. Like the AI side, we on the AI side are not really keeping up with new developments in HCI, not really thinking about these. So you can ask me about active learning later. This is like one of my key triggers in AI. And I think in both cases, we're definitely not getting ahead. So we're definitely not thinking 5 years ahead about what this is going to look like. And I think we could do better there. So the takeaways, what I will leave you with is AI is not a simple black box. Uncertainty and failure are the things that I would focus on when thinking about these. I think that most patterns roughly fit into this notion of showing and controlling versus hiding. And I think that's a useful way of thinking about this. Again, as I said, lots of good examples, no robust design language that I would say this is what you should do over and over and over again. Where I'd like to see us more work is in this, helping people actually make decisions, designers make decisions about which AI features to implement and how to think about them. And then dealing with the current trends in AI architectures, I think, is the other direction that I'd like to see us doing more in. And with that, I will let you guys ask questions. Thank you.
A few minutes for comments, feedback.
You can tell me I'm an idiot too, that's fine. No one's willing to raise their hand now.
This is a little tangential, but what do you think about the pattern where the user assumes that the AI is more sophisticated than it is? Like, for example, Expensify was using Mechanical Turk to classify people's receipts and actually involving a human in the process when you would assume it's just AI.
Right. That is a pattern. So we talk a little bit about, not that specific example, but we talk a little bit about like security theater. This happens, like making you think that it's doing something more sophisticated than it is. A dumb example, I think it fits. These machines where you go and dump your change into them, like at the grocery store, and they give you back, a receipt or whatever. Those things make a lot of noise, and that noise is unnecessary, right? It is this very theatrical thing that makes you feel good about putting your money into this black box, okay? So you feel more comfortable in using this thing because it makes a big show of doing this. I would argue that this is a little bit the same situation. I don't think they want to acknowledge that there are human beings looking at receipts. Like, that would make me uncomfortable in terms of privacy and whatever. But telling you, and it's an AI system, then you become more comfortable. I think in that particular case, I would say that they were a little bit more malevolent than benevolent, because I think the benefit to them was much more high. Like, I think they actually did not have a very good AI solution and were hiding that.
My question is about at one point you mentioned, the giving lying for saving a life, and how at that point you might actually be tolerant of benevolent deception. And how do we know that we're in that space? Because, let's say, obesity keeps growing and, diabetes keeps growing, and all these devices for these things are just failing, and we're trying to give, like, honest feedback to people, and it just doesn't work. Like, the line just keeps going. Should we start doing benevolent deception to, like, people who might be at risk of, like, obesity or diabetes or something with technology?
That's a hard question. I'm generally against lying to people in that situation. But you can reframe the question in a slightly different way. You can ask the patient, do you want to lose weight? Do you want to stop smoking? Do you want your health to be better on these particular dimensions? And the next question is, do you care about how I get you to that point? So if the person says, I want to stop smoking, and you, the system designer, do whatever you want to make that happen, at that point, I think lying might be okay. So when you go and try and charge a cigarette pack at the store, and the AI system says, I'm going to lie and decline your credit card for you. That's a solution, but the person has bought into it, right? They've said, I want to stop smoking. And so in that case, like deception might be a little bit more appropriate. It's a value system. Like I don't know the answer to that, and different people will draw the line in very different places. Yeah.
On the active learning side of things, in your opinion, is there like a strong end user incentive to like if they know that the system is like manipulating their experience to maximize like the effectiveness of the learning, right? Like, are people aware of this? Like, do they care? Do they mind?
So with active learning, so this is my little my issue with some AI designs. There's an assumption by a lot of AI engineers that like people are willing to sit there and do these labeling tasks. Is this better than this? Is this better than this? Is this better than this? Now the problem is like people are sometimes willing to do that because it improves their situation. The kinds of questions most of these AI systems ask are not like, is this very clearly different thing? You know, are these two things very clearly different? Okay, the AI system knows the answer to that. The places where it's confused are these really hard borders between. I think I had. Let's see if I have this. Right. This is easy to distinguish, which is clear, A or B, right? You can tell me which one's easier to tell the difference. This is hard. And this is the kind of thing that active learning systems are often asking people to do. Is this one different than this? Is this one different than this? Is this one different than this? That's a pain in the butt. People aren't willing to sit and do that. So I think that's where like the engineering expectation that people will actually give you this kind of feedback, it just doesn't hold water. Like I think people get frustrated and annoyed. And there's some research, Salima, Amarshai, Maya Chakmak, they've looked at this kind of problem and have basically done different kinds of studies to find better ways of presenting active learning decisions so that people are actually willing to tolerate it. So actually asking, so even though the computer knows the answer to this, I'm going to ask you this kind of thing because sometimes making easy decisions is actually nice for the interface, for the experience. Like you don't want to constantly be challenged by these hard borders or hard edges that are hard to distinguish. Does that make sense?
What's like one major category of AI that's already in use inside of user interfaces as essentially accelerators? At some level, you gestured to this with Krzysztof's project on the word toolbar. But if you think about what, say, the Google autocomplete does, or when you double tap or whatever you're supposed to do on your phone now, and it makes suggestions like apps that you might be switching to, these are all essentially, in that mixed initiative framework, like low cost of failure, high possible benefits.
Right.
And it seems like those were neither about showing or hiding control and uncertainty and so on. It seemed like they were trying, maybe their goal is different. Like, how does that fit into this framework you're trying to pitch?
I'm not sure that they're different. I would actually say that they're making a hiding decision. They have high confidence, and there's a low cost to being wrong. So there's a bunch of different things you might type or might want to do, and I'm just going to pick the top three because it's fine, or just do the thing for you because it's fine. I think from the mixed initiative framework, that is a situation where the value is high, the cost of failure is low, and I'm just going to do it, right? So that's a situation where you just, like, the AI is good enough that, like, it can sort of mask out the uncertainty.
Isn't everything a hiding decision? Because I can always arbitrarily extend my best end list, right?
Right, but in some right, this is a design decision. Do I want to show the top n, or do I just want to show the top one, or do I just want to do the top one?
Right.
And I think that's a design decision that is. I think in all these cases, like it's a function of the actual use of this technology. Like, how is the AI subsystem being used, and how good is it?
So it doesn't seem like that decision from that perspective of show versus hide is actually more about like how much am I showing, right?
Yeah,
because you're always hiding something.
Right. No, and I don't think like these don't need to be mutually exclusive. Like there's some things in between, right? Like you can think of interfaces that combine features of both showing and hiding. I don't mean to argue that there's exclusively one and exclusively the other. Yeah. Go to the back.
So on the show-hide spectrum, where does metacognition come into play? And I ask that because it could play into concealment and the fact that you're deriving these patterns under the surface, that at the end you show, look, here's data visualization of your habits. But also from from a showing perspective, by doing little, essentially formative assessments along the way, these are your patterns along the way. You can help somebody to tweak what they're doing. And I come from an educational perspective, so if you want to put that into a bucket, an education or a learning experience, the AI is helping you to derive better patterns or habits at the end. Where does metacognition play in that conceal or hide?
That's a great question. I don't know. To be honest, I haven't thought about it that much. Did you have some insight or instinct around this?
In my mind, it depends on the audience, as it always does. If you're dealing with what they call mission-driven learners, which are usually adults, they really know what they want at the end. And the concealment's really great because they don't really care about the process as much. But if you're dealing with, say, an adolescent, that really needs to reconfigure how they're learning as they go, because there's so many little things going on that they're just not aware of, then maybe showing as you go is better for an adolescent audience.
Okay, I buy that. Yeah, I mean, I buy that there's differences in pedagogy and andragogy. Yeah, I mean, I think that's reasonable. So, yeah, I guess that's true. In all these cases, you might factor in the end user and sort of their expectations. And yes, the motivation and incentive structures are quite different. So, it's a good point. I haven't thought about it that much.
Why don't we hold the other questions? You can go mob Eytan after, friendly way, mob Eytan after the end of the talk. Let's thank him one more time for coming.
Thanks, guys.